So I guess I'll start. Welcome to Computer and Network Forensics. My name is Brandon Luca. I go here. This is a slide that's a little bit about me. So I graduated in May. I got my bachelor's in computer science with a minor in information assurance, which is cybersecurity. I'm currently here still doing my master's in information systems. I'm a cybercore scholar, which is one of the main security scholarships on campus. So if you're interested, come talk to me after about it. I'm the co-founder and ex-president of this club, of which Tristan is the president now. So I'll pass on the torch. But I'm still here doing a workshop. After I graduate, I'm going to be a cybersecurity engineer at MITRE, which is in McLean, Virginia. It's a government contractor, sort of, just to put it simply. Some of my past experience, I was an information security engineer at the GSA last summer. Throughout college and summers, I was an assistant systems administrator at the Union for Reform Judaism, which is in Grand Central in Manhattan. I was a student intern at the Applied Data and Networking Science Lab, which is now directly above us upstairs, which is also the cybersecurity lab here. And back in high school, I was a field tech for the New York City Department of Education. So it's just a little bit about me. But now, why we're here at forensics. So the main goal of forensics is to answer the questions of the legal system and nothing else. We conduct an investigation. The prosecutor will tell you, we need this kind of evidence to prove this, and you look to that evidence. So you apply investigation and analysis techniques to gather and preserve evidence for a particular computing device in a way that is suitable for presentation in a court of law. Because everyone knows that when something's in court, everything has to be perfect, otherwise it'll easily be ripped apart by a defense team. So in terms of computer forensics, there's two main parts. There is looking at a computer, or actual computer, or looking at network traffic. And they're both extremely important. So you might think, why do I want to know anything about forensics? Well, every profession in the computer world pretty much requires forensics, or at least some knowledge of how things work. Just a couple of things I pulled out. For data analysts, they might need to do data recovery, which is also a forensic thing, looking at a hard drive and examining bits to see if they can find the file, as well as consulting to see if they're even able to fix a problem like this. For malware analysis, they have to analyze changes to the operating system, meaning they have to see what happens after you run the virus. In order to do that, you have to know a lot of things about Windows internals, Linux internals, etc. Networking experts have to be able to conduct network forensics, meaning they have to be able to monitor protocols, traffic flows, and read packet captures, all of which we'll do later today. That's just to understand network traffic, see if any important files are being exfiltrated or sent out of their server to someone that's not supposed to have them, whatever, just monitor things. Also, system administrators have to conduct log analysis. They have to view hidden files all the time, because hidden files contain information that may be important to them. And they might also have to do PSP analysis. If any of you have ever worked help desk and you've worked with Microsoft Outlook, you would know it's a horrible program. It breaks all the time. And a lot of times it's because of the PST file stores all of the mail data that's downloaded to the computer. And that breaks all the time. In order to recover it, you may have to do some analysis on it. So before I get into all the technical stuff, I just wanted to give a little bit of theory, just to explain why some things are done the way they're done. Every piece of evidence, whether it be physical or computer, has a chain of custody document along with it, and that describes who has what item and when did they have it. So if I have the gun from a murder case and I'm giving it to somebody else, they have to sign a form that says that they got it. So everyone knows who had control of that. The whole purpose of this thing is to make sure evidence is not accessed by anyone without the authority to access it. And this is important for computer forensics too, because if I acquire a hard drive from a computer and on one day and it looks like this, and then when I go to present it in court, it looks like something different, then it's not admissible anymore, because it's not the exact same thing that I got. So picture in the top left corner is a hardware write blocker. And what that does is it prevents your computer from writing to the hard drive and making any changes. Because even when you plug your flash drive into your computer and you're not copying any files over, your computer is still making minor modifications to the hard drive that can change the entire hash value, which I'll get into later. And that would immediately make anything you do with that hard drive inadmissible. So you have to be very careful with that. Yeah, so as I said, this all has to do with accuracy and integrity, which means that you have to use write blocking, and you have to use hashing before and after the investigation to verify that this is what I started with, I did my investigation, I ended with the same exact thing, and no changes were made. A lot of other important data can be found when conducting a forensics investigation, such as metadata on files, which can tell you when a file was created, what user account on the computer created this file, and other things. So copying data always changes. I don't even know what I wrote there. Copying data always changes. I'm not even going to talk about that. Okay. So if you were at the NCL training on Tuesday, I gave the same exact explanation of hashing. Does anyone want to tell me what hashing is? If you weren't here on Tuesday. Anyone? Okay, anyone want to guess? Okay, cool. So I explained hashing with Humpty Dumpty because things happen one way in hashing, especially with forensics. So Humpty Dumpty sat on the wall, had a great fall, and no one could reassemble him after that. So every file has a unique hash, whether it's a string or an actual file itself. This is used for encryption to hide data, as well as verifying that data has not changed. So as I was saying before with the write blocker, if I acquire a hard drive on this day, and I take a hash of it, I'm gonna get one string. And if I conduct my investigation, at the end, if I didn't make any changes and I didn't ruin the hard drive, I should be able to run the hash again and get the same exact thing. And that's what proves that from beginning to end, nothing was changed. So everything can be presented in court. You can't go backwards from a hash unless you have the key or unless you know what the original text was. So in forensics, we use one-way hashes, meaning we're just using them for integrity validation. So a hard drive with one hash will only be the same after investigation if the hash is taken at the beginning and end of the hash. Everyone good on that? All right, so forensics experts are expert witnesses, and they're the only expert witnesses can give opinion evidence in court, meaning that they have some sort of qualification that they can look at something and say, this is what I believe happened to it. There's two different types of investigations. There's legal investigations and corporate investigations. The stuff I'm talking about right now is mostly for legal investigations, because that's all stuff that holds up in the court of law. If you're just looking to see whether or not one of your employees is doing something stupid, you really don't have to do this. You can do it in a corporate investigation where there's not that many rules and you can just go crazy and try to figure something out. All right, so everyone has their Windows VM open, right?
It's actually still kind of loading Windows.
All right, cool. Well, I'm going to keep going. Everyone else good? Everyone has it open? All right, cool. So we're using Windows 7. So I gave this workshop 2 years ago, and I used Windows 10, but it was too beefy, so I just moved everything to 7. It doesn't matter. But with that, don't use this virtual machine for anything outside of this workshop related, because Windows 7 is very vulnerable to things now. It's kind of out of scope, so I'm not going to get into it, but just don't use it for anything personal. Don't put your credit card in it or anything like that. So it has Firefox on it. It has FTK Imager, Autopsy, a hex editor, SysTools Outlook PST Viewer, Wireshark, and the SysInternal Suite. And we're going to wind up using all these tools today. All of these tools, well, I shouldn't say all of them. FTK Imager, Autopsy, and Wireshark are tools that real forensics experts use, and they actually don't cost money. There's FTK Imager is like the child of a larger program called FTK, and that program costs like $10,000 and it can do a lot of crazy things. But I'm poor and I can't afford that, so we're using the Imager. Okay. All right. So I'm just going to talk a little bit about file systems before we get into anything hands-on. So Windows uses the NTFS. You've probably seen that somewhere if you're ever formatting a drive. That stands for New Technology File System, and it's shaped like that. You can usually recognize a file system very easily based on going to the root or the top level and looking at how the folders are arranged. So this would easily tell you that this is a NTFS. If you just looked at it, you would know it was Windows. The primary drive is always assigned to C, which holds the operating system. And the most important system folder on here is Windows System 32, which contains all of the log files, DLLs, which stands for Dynamic Link Library. Also out of scope, but that's kind of just like a program dependency. Like whenever you open a program and it needs extra data, it will call upon a DLL. I'm not going to talk about it. As well as other system programs like command prompts and things like that. All right, so you can view, so whenever you look at like a hierarchy like this, none of the hidden files on the system are actually showing. There's actually a ton of files that you can't even see. So what I wanted to walk through with you guys is how to show the important system files on a Windows machine. So I'll walk you guys through this. If you open up your Windows VM. Technical flaws. So if you go to the start menu in the bottom left corner and go to control panel,
Bless you.
and if you go to appearance and personalization, in the bottom right underneath the folder options, there's an option for show hidden files and folders. And then that'll bring you to this pop-up over here. And underneath the hidden files and folders option, I hope you guys can all see it, just put a bullet in the box for show hidden files, folders, and drives, and hit apply. Just give me a thumbs up when you're doing this.
Sick. Appearance, personalization.
Yeah, and then underneath, there's a folder options thing here. Underneath that, there's a quick thing for show hidden files and folders. And then you can just enable it. Give me a thumbs up if you're good. Good. All right, so now with that enabled, we can go into the File Explorer on the bottom, just any Windows Explorer. Go into Computer and look at your C drive. And you'll see one new folder popped up, and that's the Program Data folder. But unfortunately, this is like pretty much not that useful. There's a lot of files that Windows won't even show you, even if you tell it to show you them. So I'll get into that now. On some versions of Windows, like Windows 10, when you run that, you'll be able to see a couple of important files that exist in the root directory, which is what we were looking at. One of them is hibernfile.sys, and that's only there if your computer has hibernation enabled, which hibernation is pretty bad, so I actually suggest you use it. But what that is when your computer is about to die, it might go into hibernation mode. So it saves the entire state of your computer, everything open, into one file. That's like 40, 50 gigabytes when it dies, and then it just recovers from that file. So if you're ever wondering, if you have Windows 10 and you have hibernation on, you're wondering where all my space is going, do this and look for your hibernation file, and it's probably really good.
Yeah, thanks for letting me know that, because I'm trying to turn that off, and I'm like, I don't care, let my computer die, stop trying to save it, don't patronize me, Windows. But don't you want it saved? No, kill it.
Yeah, so Windows it really won't let you turn it off, kind of. Like, you have to go into like the registry to turn it off, but you can just delete the file and then just keep deleting the file. So then there's pagefile.sys, which is virtual memory, which is things taken out of RAM and saved. We're not really gonna get into that. And then there's the application data folder, which has cookies and other things users don't have easy access to. And that's stuff that on Windows 7, it would be in that program data folder. However, like on versions of Windows like ours, you pretty much see nothing. And there's a lot of stuff underneath the surface that can be really useful to a forensics investigation. So on your desktop, there is a file called Hex Editor Neo. And this isn't some sort of forensics tool. All this is a hex editor. On your VMs, I did not open it beforehand, so when you open it, you're gonna have to say you want a 14-day trial. If I think so. So when you open it, we're good. Well, okay, you're gonna have to. All right, maybe that's not when you do it. All right. So go to File in the top left corner, and then hover over Open. And what we're going to want to do is we're gonna want to open a volley. And we're going to use the C drive, which is the drive that has all of our operating system files on it. And OK. And now is where you might get hit with the trial. Okay. And then after you accept the trial, you might have to go back into File, open, and open it again. Just give me a thumbs up when you're good.
In Hex Editor Neo, we were supposed to have
Yeah.
14-day trial.
It's like a blue diamond thing on the desktop.
Yeah, no, I have that up. I didn't get a 14-day trial.
Yeah, it's, I don't know. Did you try opening the C drive? When you open the C drive, I think that's when it's going to give you the file. Okay, so if you look on the top right corner, the volume navigator, you're going to see that there's a lot more folders than it likes to show you, and there's also a lot more files than it likes to show you. You can see the pagefile.sys, which you weren't able to see by enabling hidden files. There's also a bunch of other important stuff here. Mainly, the one thing that I'm going to talk about is the MFT, which stands for Master File Table. But another thing I wanted to show you is if you scroll all the way up, so on this view with all the bytes, if you scroll all the way up with this scroll bar to the first thing, you can see the first byte of your computer, because the first byte of your computer is always going to be the thing that allows your computer to turn on. So if you look, it starts with NTFS, so it's telling like the CPU that it's running with an NTFS file system. And if you keep going down, you can actually see, you can't see the actual code behind it, but you can see sort of like an error catching thing where if you don't have a boot manager on your machine, it's gonna print the error message. So it says boot manager is missing and or boot manager is compressed, so you can kind of see what's going on. So that's how your system starts. And then in the top right corner, if you go to $MFT, it's gonna bring you to the point in memory where that file is. Which for me, it opens up on the bottom, so I'm just gonna scroll a little bit. So it'll start with file 0, and then it'll have a bunch of unreadable text by us at least, and then it'll say MFT, which is the name of the file, and then it continues to have a lot of more data about the file, like when it was created and stuff like that. So I'm gonna talk about that now. Yeah, so the MFT is the master file table with a record of every file in the system or every file that's ever been in the system. So if you have a Word document on your desktop and you create it, it gets added to the master file table. And then if you delete it, it doesn't get erased from the master file table, it's always there. So that's a good record of, if you're looking for something with a specific document name in a forensics investigation and you want to see if it was ever present on this machine, a good way to do that would be to open the MFT and do a quick Control F and look for that file name. The MBR is the thing I showed you at the top, the master boot record, and that's the first thing that's loaded when a system turns on. It contains the name of the file system along with the instructions to load the operating system. Cool. All right. So I don't wish that's open. All right. All right. So now this is where things get tricky. Now I'm going to need you guys to switch over to the Kali unit. So I'll give you guys like 2 minutes. There's a lot of switching. If your computer can't handle it, I'll turn off the Windows one and then wait.
Yeah, so it's fine, I downloaded,
So just open up your Kali one, and then we're gonna go back to the Windows one.
yeah, so I don't need to like do the hex thing now, right?
No.
I can skip that, okay, cool. I'll just pause it. Alright, Kali.
Does anybody need Kali for VirtualBox?
Hold on. Distracting. Yeah, it's just distracting. Did you need to speak up or?
No, I was asking if anybody needed Kali for VirtualBox.
It's the thing you sent like last time, right, on the Discord or on
No, the Kali Linux.
Is everyone's Kali turned on?
Yeah, it's basically a RAR file, right?
We have time. There's not a lot of it, so we can move forward.
It's like, yeah, that's extracting like right now.
I know the actual
Alright, let me just.
file and
Alright, cool, thank you.
Yeah.
Thank you.
We're using VirtualBox, right?
Virtual VMware.
.over fine, actually. Yeah, it's just the Kali Linux. Yeah.
Where's the list we need?
It's always better in the dark.
Alright, we good? Everyone sort of decently good? Ready? Alright, so Linux and Mac use the Unix file system, which is abbreviated by UFS. This is present on all Unix machines, including Mac OS X, and it's formatted a lot differently than a Windows setup. So here I have a screenshot of, that's not what I want to do. Here I have a screenshot of my Linux, and yours should look exactly the same. Just to show you guys on Mac, it looks exactly the same. I'll do it here also. So Mac adds other things that Apple wants us to have, and at the end of the day, you're still going to have bin, dev, UTC, all the same sorts. So yeah, so in your Kali image, if you open it and you right click the desktop anywhere on it, and you click open terminal, I'm not gonna give like a command line tutorial today, but if you just type CD with a / in front of it, that's gonna bring you to the root of your drive.
Asking for a username.
Root. Password is TOOR, root backwards. Alright, so if you type CD /, that's gonna bring you to the root of your hard drive, which is the top level of the same thing that we were doing in Windows. And if you type ls-la, you're gonna see sort of the same screenshot that I have, and all of our systems are shaped exactly the same way. So that's a good way to do this file system. So this picture, I was gonna print it out, but I forgot to, just to give to you guys. But it's a good layout of all these folders that you can see when you type ls, and then you can see what is present in each of these folders. So for example, the bin folder contains a lot of programs that you use, like almost all the time. Like we just use ls, and ls is a binary that's present inside the bin folder. The home folder is very important. The home folder will contain all of the users on a machine. etc contains configuration files, boot contains boot files. They each have individual purposes. Some of the more important things that might be useful in a forensics investigation that might not be useful for other things. There's a file called etc shadow, which is kind of the brother of a file called etc password. So these are two files that store all the usernames and passwords on a Linux machine. The difference is that shadow will contain the passwords, the actual passwords, and you can't view them because they're encrypted. And usually people don't have access to that file. But if you had access to that file and you were able to crack password hashes, maybe you can actually get someone's account logged in, which is pretty interesting. There's the temp folder, which contains virtual memory. There's the home folder, which, as I said, contains user directories. And then there's the var folder, which stands for variables, but mostly there's a few log things inside var, two of which being the spool, which contains mail files, and /log, which contains all system and app logs. So.
And the password for Kali is roots, right?
No, the user is root, and the password is root backwards, TOOR.
Oh, okay. Thank you.
Okay, so this is my next forensics point. So when you save a file, and you know how all files have the dot whatever the file is. So if it's a JPEG file, it's .jpg. If it's a Word document, it's .docx, PowerPoint.ppt. So a file's extension is how the system associates that file with the program to open it. So when Windows sees that you have a file called .docx, it knows to associate that to Microsoft Word. But that's not necessarily what the file actually is. So extensions, all they do is relate to programs, but a file can be anything with any extension, it doesn't really matter. So you can modify the extension, but you can't actually modify the contents of the file. So the way computers actually do this checking, apart from the program side, is with a thing called magic numbers. And I'm gonna open up this website, just to give you guys an idea. So a magic number is the first few bytes of a file, and this is what determines what kind of file it is. So for Word documents, for docx. So docx has these initial 4 bytes at the beginning of the file, 54B0304, and in English that's PK. So when you see something like that, that's how you know that's how a computer knows it's actually a Word file, not by the extension at the end of the file. So the Linux tool file is often used, whether it be on a website or just for security challenges or whatever. That can be used to read the magic number of a file and tell you what kind of file it actually is. So I'm going to demo this, but I just wanted to say that this also has a lot of pen testing applications. If you're working to try and break into a file upload site, and the file upload site says it only supports PNG files. So then you upload a file with a PNG extension and it works. And then you try to upload a file with a docx extension, or you want to upload something malicious, you try to upload that and it says it doesn't match. So what you could do is to trick the system is most of these machines are running file on the other end. So if you want to trick the system and make it think that you actually uploaded a picture file, for example, all you got to do is go to that website that I pulled up, if I can find where it came up. you find the magic number for PNG, and you just plant that right in front of anything else is in the file. And then it'll allow your file to go through. And if it's an executable file, odds are you'll be able to run it. So that's a good way of thinking about how that works. So I'm actually gonna demonstrate this in Kali. So what I'm gonna do is, let me try and make it bigger real quick.
At the root?
No.
So I mean the terminal, sorry.
Yeah. You guys don't have to follow along. You guys can just watch if you guys want. So I'm going to go, I'm just going to make a file on the desktop called hello.txt. Alright? And in this file, I'm going to write, this is a test file. It doesn't really matter what you put in. And now we have this file on the desktop called hello.txt. So now what I'm going to do is I'm going to change the extension to JPEG. So people think it's a picture file. You notice how instantly the operating system changes the default program that's going to open it from your text editor to a picture viewer. But if you were looking at a file like this and you were a forensics examiner, and you were looking at the contents of the file, all you have to do is run file on hello.jpg, and you would see that it's nothing more than just text. And then you can read the inside of it. So the extension doesn't matter, is my point. All that matters is the magic number. Because this text file, no matter what I do to it, is always going to have the magic number of a text file. So that's how it goes. Cool. All right. Doesn't pick track of that. Awesome. So now I want to talk a little bit about steganography, and maybe we'll do like a steganography sort of challenge. So there's a few important Linux tools for forensics, and there's a challenge on the next slide that we're going to go through together after you guys like mess around with it for a little bit, that actually utilizes all of these three tools, which is pretty cool, I thought. So there's three different things. There's strings. The way you use strings is you run strings on a file, and that finds all human readable text inside it. So normally when you run strings on, let's see, find something. So try something like this. Yeah, so I ran strings on a JavaScript file and it gave me the code, but if I was to run strings on a not file like that, I'm trying to see if I have an example. Oh yeah, for example, so I have a shortcut to HIDA, which is a reverse engineering program. And if I run strings on that, it's going to give me all the metadata about where the program is actually located. So all that stuff is present inside the shortcut file. But this is useful for steganography challenges where you're looking at a picture and none of that stuff is going to be text, it's all going to be random bytes. So oftentimes people will hide things inside picture files for people to find. So there's another tool called StegHide, which is a pretty popular tool that uses, I forget what algorithm exactly it uses, but you can hide files inside of other files. And you'll see how that works in a little bit. And then there's binwalk, which stands for binary walk. And what this does is it examines a file for other magic numbers to find other files within a file. And that's kind of a mouthful. What I mean by that is when you use StegHide and you're trying to put something inside of another file, sometimes it might be undetectable depending on what kind of algorithm it uses. But a lot of the times people will just try and copy and paste it inside it. And when you copy and paste another file into a file, obviously somewhere throughout the course of that, you're going to hit another magic number when that should not be present again. So what binwalk will do is it will look for another instance of a magic number, and it'll tell you, oh, we found this sort of file inside this bigger file. And it'll be able to pull it out for you. Cool? All right. So on the desktop of your, well actually no, not on the desktop of your Kali machine. So in your Kali machine, open up a web browser and go to that link. I tried to make it short. There's going to be I forget if I uploaded a zip file or an actual folder, I'm not sure. Either way, download that, and inside there is going to be a challenge that we're going to walk through. The link works, right? Anybody?
Yeah.
So when you guys had downloaded it, someone tell me, was it a zip or was it just a folder? It was zip, alright. So it's probably saved to the desktop, to the downloads folder. So just go into your downloads folder, just open up the terminal.
What was that again? I was typing, I think I mistyped it.
Type what?
I think I mistyped.
Link?
Yeah.
The caps matter.
I know. Oh, yeah, that makes sense.
So type the command cd, and then the little squiggly line that you never use, which is underneath your escape key, type that with the / and downloads. Unless when you downloaded it, you click open and then you have access to inside the folder. In that case, just drag it out somewhere, like the desktop. But if you didn't do that and you click to save it, all you have to do is type unzip and then the name of the zip file, and it'll unzip it for you. Anyway, your folder at the end of it should look something like this. And I was gonna put this on the machine, but this was kind of a last minute thing, so I added the weight. Now we have to go.
So what we do next is that we just, what are we typing in again?
For which?
For the DaVinci thing.
You said you downloaded it.
I downloaded it. That's not the right thing.
See what you downloaded?
Yeah. Download.
Don't click it. Just drag that folder out.
You said we go into the terminal and.
Yeah, just make sure you're in the same folder as this with your terminal. You can just right click anywhere, empty space in the folder, right click and hit open the terminal. Can you guys help him? Someone? Hello? Executive board, help him. Alright, so does everyone have a terminal open in this folder? And you see what I'm saying, where you right click into an open space, you just open a terminal on it? Alright, so you have these 3 files. They're all JPEG files. I'm gonna leave the slide up with the commands, and I'm gonna give you guys maybe 5 minutes just to mess with it and see if you guys can uncover anything. You might not know how to use snake hides and get into that, but just try running strings and walk and see if anything pops out. That's not normal. Yes. That's not
I guess what it's an issue with.
That's right.
Just extract it to your downloads and then open the terminal. It doesn't matter.
It doesn't matter who as long as you get that.
Well, now I'm just getting errors. I keep saying there's an error. So yeah,
Just try that, please.
Yeah.
I just did that. So extract desktop.
No. I'm looking for guest edition. Oh, wait, this is VMware.
Yeah, VMware.
Oh, never mind.
No, okay.
Yeah, you might have to deal with that resolution. You guys are good?
Should be. So we're just looking at migrating streams and turning them into this folder.
What was the link again?
You know,
What?
run
The link?
streams.
Giving those strings on the file, not the.
Oh, okay,
Yeah.
gotcha.
You good?
Hang on.
Yep.
Honestly, YouTube video.
Alright, so I'm just gonna walk through it, so just for the sake of time, and so we can actually have a 10-minute break in between. I'm gonna walk through this. So there's one thing that like I didn't really teach, and I just kind of wanted to see. Did you guys find anything? You guys run the programs and try and find anything? Okay. Well, if you ran binwalk on all 3 files, you would see that plans and the password is blah 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 don't have anything embedded in them. But interestingly enough, the Mona Lisa.jpg has a zip file inside it. So that's one of the things we're supposed to find in the beginning. Something I didn't show you is, so this file name is pretty much giving like a hint away towards the first solution to this problem. And if you work with these tools enough, you'll know that when you use SnagHide to try and extract the file, you'll have to apply it with a password, and that password is what's used to encrypt the file inside of it. So the password is the small name of the actor named Hanks, which would be Tom Hanks. So yeah, what we have to do is first we have to remove whatever file is inside this JPEG file. So to do that, we can run this command. So you're gonna do SnagHide -- extract. And then the -sf is for source file, and the source file is going to be the name of the file we're trying to look at. And after you try and run that, it's going to ask you for a passphrase. And that passphrase is going to be Tom. So I just tried Tom with a capital T, T-O-M, but that didn't work. So I'm going to try all lowercase, it didn't work. Now I'm going to try all uppercase, and now it worked. So you kind of have to like figure out how these people were making these challenges. So the password for this file would be all uppercase Tom. And that's going to give us a text file that we have now. So if we look at this text file that we have, it says, hey, whatever, this is my secret key for our folder, and it gives us a key. And he goes, I used an encryption with 32 characters, no one will find it decrypted. So we already know that there's a folder somewhere that requires a password, and that password is going to be what that key is. If you were present on Tuesday and you were there for the password cracking, you probably know what to do with this, but I'm just going to show you guys. So we kind of assume it's a hash since the password is encrypted. So we can run hash identifier. And if I can spell it when it opens. Right? So now I'm just going to copy and paste this hash into here and run it. And at the top, it's going to tell me what it thinks it is most possible, and it's telling me that it's probably an MD5 hash. So with that MD5 hash, I can take that and go crack it. So there's a popular website called CrackStation, which is what I'm going to open right now in Firefox. Hopefully eventually it opens. And my Firefox isn't working. Okay. So if you were to take that hash, if you were following along, and you copy and pasted it into CrackStation and you ran it to see if it has the hash present, you would have found out that the password is Leonardo. My Firefox isn't working, otherwise I'll show you guys. Right, so now we have a password to something. So that's kind of interesting. What can we do with this password? So we know that there's 2 other files that we can test with that password. We only extracted from one of them, and that was the password file. And we also know that inside MonaLisa.jpg there is a zip file. So we can try it on a couple of these things. So we can run binwalk -e, and what -e does is it extracts all things that it finds. That's what TAC is for. And all we gotta do is just put the name of the file after that and run it. It's gonna give you the same sort of output as without the E at all, but if you run ls to list the files in the folder, you'll notice that there's something different. There's a whole new folder called MonaLisa.jpg extracted, which is everything that it pulled out. And if we use cd to get into that folder, we can see that we have a zip file called famous.zip. Right, so if we try to unzip that now, we have Leonardo as a password, so we can try inputting Leonardo. And Leonardo with no caps works. So then we get a JPEG picture called Mona.jpg. Alright? So, with Mona.jpg, we can try running binwalk again on that, see if maybe you're gonna keep making us go deeper. There's nothing with that. And so now, let's put that aside for a second, because we never looked at the plans file. So if we, one thing we didn't run on any of these was we didn't run strings. So we can try and run strings on that one, because that's the only one we didn't get anything from it. And we have a lot of garbage here. Like as I said, if you're not running strings on a file with actually human readable text, you're gonna get a lot of junk. So this is what, these are the human readable characters, like ASCII characters that are visible in a picture form. But at the end of it is a YouTube link. So let's go to the YouTube link. I don't even think I can load it right now, actually. Alright, I can't load it. My thing is bugging out. So this was a part of the challenge that I thought was kind of stupid, and that I actually had to Google because I kind of got lost. So that video is titled this. Guernica. Now I don't even know what that is, but that was the title of the video. And if we go into the Mona Lisa directory, and we use that password to try and extract something from Mona.jpg, we should be able to get something. Right. So then we get a file called key, and if we look at key, we'll see it's base 64. So this challenge is kind of like a rabbit hole, but I liked it because it just shows you like the capabilities of all 3 of these tools. When you're doing like a forensic challenge or something like that, if you're going to do NCL, you're going to need all 3 of these too, because there is a steganography section, and this is what's considered steganography, hiding data within other data. And it's having a good familiarity with these tools is going to take you a long way. So yeah, I'm going to have like a write-up of all these things that I'm going to ship out after so you can see all the commands, but just so you guys can get an idea of how it works. And if I decoded this, that would be like the answer to the challenge. Alright? Cool? Alright, now, I'm going to be annoying again, and now we have to shut down Gallery and open up window. So I'll give you guys a second. guys have your windows up. Alright, everyone have windows up? Good? Alright, so now I'm going to talk about the difference between physical and logical drives. So every computer has a hard drive or a solid state inside it. This is what's considered a physical drive. So this is a completely separate, actual physical thing that exists. However, one physical drive can have many logical drives, and if you ever partitioned your computer or partitioned a hard drive, you've made a logical drive. So the computer thinks of it as another drive that's attached to it, however, it's just a separate piece of the one you're already using. So on the Windows VM, there's two partitions. There's going to be the C drive partition, which has the operating system, and I also made a 1 GB partition called Forensics, which we're going to be working with. So the way that you can see that this exists is by, in the bottom left corner, going to the Start menu. Then there's Computer here, and if you right click on that, you go to Manage. It's going to open up the Computer Management. And in here, there's going to be the disk management option. Yeah, so here, the two partitions are listed. There's the C drive, and then there's the forensics drive. And it tells you that the C drive is using NTFS, and that the forensics drive is using a different file system called FAT32. I'm not going to get into FAT32. It's basically just, FAT32 is mostly used for storage, and it doesn't really, so NTFS is used for Windows because a lot of complicated stuff is happening in the background, as far as like logging and writing metadata about files. But FAT32 doesn't really care about any of that. It's just mainly for storage. So most of your flash drives will be using FAT32. All right. Picture of what it is. Yeah, so in the same computer management thing, there's also the event viewer. So if you didn't close it and you're still right here, there's the event viewer here, which I'm also not going to get into today. But that basically keeps track of all the major events on your computer, whether it be a new piece of hardware was added, a new driver was installed, the computer shut down unexpectedly, here's why, stuff like that. I've even found it to detect when you have your computer plugged in and there's like a sort of like a power surge and your lights go on and off, and it actually logs that there was a little bit like extra dose of electricity was delivered to the computer, which is pretty cool. Yeah, that's it's very critical for forensics examiners to look in here and figure things out. So we don't have to go back into Linux, but as I said before, as the same way you view the logs in Windows with Event Viewer, you can view them on Linux just by looking at the files. So there's a directory called /log, which was on the previous slide before. And there's 3 logs. There's syslog, offlog, and kernlog, which are very important. Offlog is important because you can know who logged into a computer at what time, which is very useful. That's a good way of determining whether or not someone was present at a location, depending on where the computer is physically located. Syslog contains program and system logs, and syslog is like the biggest thing right now. Everyone's trying to direct system logs to whether it be a Splunk instance, which I think we're going to be talking about later in the semester, right, Ivan? Splunk, yeah. Okay, so that's important. And what they do with those system logs is they try to look for abnormal activity to try to determine whether or not someone's infiltrated the system. And then there's the kernel log, which would be extremely important if a virus or a hacker was trying to actually destroy your computer, because once they get to the kernel, it's all over for you. Okay, so now I'm just going to talk about how Windows treats files, mainly Windows, but pretty much all operating systems. So when you make a text file and you write like hello in it, for example, you would think that it would only take up the space that you're using. Like it would only take up the amount of bytes that it takes to say hello. Well, this is not true at all. So there's a thing called slack space, and I can show you guys here. So even I made a file called slack space test before, and in that file, all I did was write, this is a test file. So the size of that file is 22 bytes. It took 22 bytes for me to write whatever I wrote inside it. However, the size that it's actually taking up on the disk is 4 kilobytes, which is like thousands of times that. So why does that happen? So the way computers organize files is that they do it by chunks. And why they do it by chunks is that when you're defragmenting a hard drive or trying to analyze like where files are together, it's easier to do it in where every file has the same size to make it easier to move around and link things back together. So you can see this if you've ever formatted a drive or formatted a flash drive. There's this thing called the allocation unit size, which is also known as the chunk size, and that's 4096 bytes, with the same way that the size on the disk of this file is 4 kilobytes. So when I create a new file, no matter what I do with it, it's going to increment in sizes of 4096. So if I had gone over the 4 kilobyte limit, whatever I put in my file, this would be 4096 times 2, 8192, no matter how much it is in between. So this stuff in the middle is called slack space, and there's been a lot of instances of people trying to hide data in slack spaces. We can actually try this out ourselves. So if you guys go to your Windows VM, and on the desktop, right click somewhere and just hit text document, and just make a file called anything. You can name it test. And then open it up and type something you want into it. It doesn't matter what you type. And then just save it and close it. Now if you right click it and go to properties, you'll see the same exact thing that I was showing you guys before about the difference between the size and the size on disk. Cool. So now if we open our hex editor Neo, the top left corner, you're gonna get your trial thing, just say continue trial. Now instead of opening a whole drive, we're actually gonna open that one file. So just click on open file. Mine's on my desktop, so I'm just gonna navigate to my desktop and open test.txt. So here's where you can see the actual shape of the file. So there are these bytes at the beginning, these 6 bytes. So the 6 bytes are my LOL and my space and then hi. But after all of this, there's just a bunch of empty space. And these are bytes that haven't been written yet. So you can come down anywhere underneath that and you can type with the editor and you can say, this is a message that I'm hiding. And then you hit Control S and save it. And then once you save it, go try to open up your test file on the desktop again, and you'll see that nothing has been changed to it. Actually, it might be over here. Okay, so this is probably a bad idea to do with a text file, but so yeah, it just adds it to the end because the text file is just empty bytes if there's nothing else in it. But if you're working with like a picture file or something like that, and you were to write into the slack space, it wouldn't come up because it wouldn't be detectable by whatever picture program you were using, and you wouldn't be able to drag to the right and see it. It would just be in the file space. There's been a few instances of spies communicating with slack space before. I couldn't find an article about it last night, but maybe like 5 or 6 years ago, I was reading about Russian spies on eBay trying to communicate outwards information back to their country. And the way they did it was that they would upload items to eBay with pictures of the item, but inside the pictures of those items, they would use the slack space to type messages. So they would just upload an item, like a picture of the item, and they would tell somebody, maybe in Russia, that, oh, this is the item that contains the secret message. So they would navigate to the item, save the picture, and then open it up in something like that. Just scroll to the empty space at the end of the file and look to see what they wrote. And that's undetectable by eBay because it's still a picture file, it's still gonna work normally. Unless you're really looking for it, you're not gonna find it. So I thought that was pretty cool. All right. Okay. So another thing we can do is we can recover deleted files. When you delete files, odds are they're not gone. So the way Windows files work is that when you delete a file, that file kind of remains on your disk, and Windows will tell you it's free space, but it's really not. The original file still exists, like as far as zeros and ones are concerned, and the file is only deleted when it's eventually overwritten by other data. So famously used tool, the whole Hillary Clinton email scandal, famously used BleachBit, and what BleachBit does is it will go over an entire hard drive and rewrite data. So if you have a hard drive and you format it, odds are it might not get rid of everything, but the only way to get rid of some, or like data on a disk is to overwrite everything, so it's not present anymore. So what bleach bit does is, it runs over your whole hard drive with like maybe all ones, then changes it back to all zeros, so everything is permanently overwritten. So yeah, if you don't do that, then things can actually be recovered with forensics tools. So on the Windows desktop, I have a program called Autopsy. You don't have to open it yet. And then I also have a folder called Files to Delete. So if you open up the Windows Explorer, and then go to Computer, we're gonna use the partition I made for this. The forensics partition. Just open that up, and also open up the Files to Delete folder. And what you're gonna wanna do is just copy and paste all of them into the forensics drive. And give me a thumbs up when you guys are good. Good. Okay. Now we're gonna wait like 30 seconds. Because if you delete them right away, then maybe they didn't finish actually writing it in the background, so we just wanna make sure they actually save it. Okay, so now what we're gonna do is we're gonna delete all these files. Just right click them all, delete. They're gonna ask you if they want them to go to the recycling bin, say okay. Then go into your recycling bin and delete them again. Good? After you do that, you can open Autopsy. It's the picture with the dog. It's pretty beefy, so it takes a little bit to open. It's moving slow. And then when it opens up, you're gonna have options here. They're pretty small on mine, but the top one says new case. So it organizes everything into cases like as if you were actually doing an investigation. So it's just gonna ask you for a case name and a base directory. It might already be set to the desktop. Just give it a name. I'm just gonna name it 1, because it doesn't really matter. And just make sure it saves to your desktop. Then you can hit next and finish. And it's gonna make it. Okay, so once you've done that, you're gonna have this screen that comes up eventually. Eventually it'll load. Anyone else has come up with any problems? This is mine. Okay, mine came up. Does everyone see this, or was I the only small one? Okay, good. So what we're gonna do is we're gonna add a local disk. You're gonna hit next, and it's gonna ask you for what disk you want to add. So we're gonna add the partition that we were just messing with, the E drive. It should be the only one that comes up. And then you can hit next, and then finish. So what it's gonna do is it's gonna run a lot of analysis on that partition. But once you see something like this come up, I can't zoom it in. On the left, you should be able to see a drop down for deleted files. And mine might have more than yours because I was testing it. And I was testing it just to get the times down and stuff like that. And my autopsy just crashed. Great. But if you go into the deleted files and you click on either one of the tabs for all or recently deleted, it should give you a list of, it should be 9 for you guys. Does it say 9?
27.
Alright, so it's 27, whatever. So those are just ones I was using to test. But if you click on them, you can actually view the pictures in the File Explorer. So even though we recycled them, we deleted them, they're still recoverable. with a tool until they're eventually overwritten by a more powerful program. Cool. Okay. So, one more thing I wanted to talk about before getting into the last computer forensics challenge is PSD files. So these things are usually located in a user documents folder, and they store everything that is email related, stuff that's in the inbox, sent items, whatever. You can find it in the registry, but often when you're looking at an image of a hard drive, you might just want to look around since it's easier for us just to look around and find things. So yeah, they're very important. And then on the Windows desktop, there's a file called System Outlook PSD Viewer. It's a shortcut to a program that can actually open these PSD files without actually having to have Outlook, and you can browse through them. So yeah.
We're not supposed to open it.
What?
This is tools. Normally it's not supposed to
No,
open
you're good. You do it. But I'm just doing this. So yeah, so there's this challenge that I have called M57 Gene, I think it's called. So this was an actual forensic challenge that was provided in 2009, and it's still kind of hard to find a walkthrough on the internet for it. But what it is there's a folder called Computer Forensics Challenges, and in that folder are 2 EO1 files, and that's just kind of that's an output file from FTK Imager. So if I had a drive and I wanted to make an image of it, it would give me the option whether or not I wanted to do raw bytes or EO1. And EO1 just makes everything look cleaner and organized. So that's all it is. So the way we're going to look at this is we're going to look at it through FTK Imager, just for the sake of saving RAM and stuff like that, because Autopsy is really heavy of a program. So once you have FTK Imager open, just hit File, and then you can add an evidence item. And the evidence item we're going to add is going to be an image file, because we have images here. And then the source path is going to be on the desktop, and it's going to be the EO1 file. And then you just hit finish.
Cuts folder or image file?
The image file. And then on the left, you'll have this kind of tree set up. But eventually, if you dig deep enough, you'll see what looks like the top level of a Windows hard drive.
So we just add which file do we add again? The
The EO1, no, the EO1 file on the desktop.
EO1 you said?
Yeah. Alright. So, we don't actually have to solve this challenge, but I just want you guys to play around with the tool and look around for important files that the questions are asking for. So the important questions that it's asking are, well, just to kind of give you a little bit of background. So the company thinks that a spreadsheet containing confidential information was posted as an attachment on a competitor's website. So you get a copy of the computer, and what your goal is to try to figure out, I think there's 4 questions here. Yeah, so they want you to find the hash of the actual hard disk file itself, which is the hard drive, the images that you have. When did this person create the spreadsheet? How did they get from her computer to the competitor's website? We're pretty much not going to solve that one. And then who else from the company is involved? So just from this, you know that you have to find the spreadsheet file somewhere on here. So looking common places for that, and looking for who else from the company is involved. There is a PSD file somewhere in here, and that file will have a bunch of emails that will allow you to answer that question. So yeah, as I said, you can go through everything through here on the side, and it will be the same way as if you were using a Windows Explorer, and you can look in Documents and Settings. This is a little bit older of a format. This is how the XP hierarchy looked. But yeah, so the users folder on XP on Windows 10, for example, would be the Documents and Settings folder on XP. So you might want to look inside here. So just give it a look around and try and find files. In the bottom left corner, there's something that tells you hex values, which you can also set it to properties. So you can look at the dates things were created and stuff like that. That might help you find hashes also. So yeah, just give it a look around. I'll give you guys 5 or 10 minutes. And then after I'll walk us through, and then we'll break for a little bit. Alright, so just so we can take a break, did anyone find any of the files in question? Anyone find the Excel file, spreadsheet? Anyone find the PSD file? Alright, cool. So, that's alright. So there are a couple of things that you could have done here. So for the PST file, what you could have done is you could have looked from, I told you it was Windows XP, so you could have done a quick Google and figured out where on an XP installation of Office are PST files stored. So I'll show you guys where that is in a minute. And also some common locations you would often look are on someone's desktop in someone's documents folder or something like that. So in the documents and settings folder from root, we can see that Gene has a user. So if we go into Gene's user and we look at the desktop, that's going to be the spreadsheet file that we're supposed to look for. So if we have the properties pane in the bottom left corner, and this can tell us a lot of information about the file. It tells us when it was modified, created, accessed, talks to us about physical and logical size. So as you can see here, there's about 3,000 kilobytes of slack space on this file. Yeah, so that would be for that. I'm not going to get into any of the content of the challenge. So this challenge was originally, I think, to offer out jobs to actual forensics investigators. So they wanted you to develop like a whole unique report. But I'm just trying to show you guys how to use the tools. So yeah, on the desktop, that's where you would have found the XLS file. I skipped over you want to find the hash of the hard drive. And the way that you can do this is when we add the drive at the top, there's the name of the drive. There's a verified drive image option. And what that will do is it will go over the whole hard drive. And it's going to take 3 minutes, so I'm not going to let it run. But what that will do at the end is it will give us the computer hash, and that was the answer to probably one of the first questions. So if you did a quick Google also about where PST files are installed, well not installed, but stored on a Windows XP machine for Outlook, it's in a user's local settings folder. So inside Gene, there is a local settings folder. And then there's a couple of things in here. There's history, temporary unit files, but we're looking for application data since we're mostly trying to find Outlook data. So if we go into application data, who makes Outlook? Microsoft makes Outlook. So you can go into the Microsoft folder. And then there's the Outlook folder. There's a PST in here. And we're not going to go through too much of like going through the content, trying to analyze like who was talking to who, whatever. But something cool I wanted to show off is if you right click this and you hit export files, it'll let you save that file from inside the disk image to your actual computer for like further examination. So what I'm going to do is I'm going to take the Outlook PST and I'm going to put it on my desktop, and that copies it out. So now I have this PST file right here. And what I could do with it is I could download Outlook and look at it, but why would we download Outlook when we have other lighter tools that are easier to view? So if I open up the Outlook PST viewer, it's going to allow me to add a file. So I'm just going to add a file. And I'm going to go to the desktop and I'm going to add the Outlook PST file that I found from the hard drive. I'm going to add it. And it's going to scan it in. And inside here I kind of have a look of how Outlook would have looked if you had this PST file installed there. So there's an inbox and it loads all of the old emails. So this is pretty good if you were trying to look at communications between people, try to figure out who sent who what file, when. So this would all be very useful in writing a report if you're investigating somebody. So
What happens if you trash an email? Does it still find trashed emails or no?
So I'm not like 100% sure about how Outlook handles this data. I don't know when you delete something, whether or not they actually deleted, or like I said before, it has to be overwritten. Because everything's handled in that one little file. And to be honest, no one really knows how this file works. Because as I said before, it's kind of a file that breaks all the time. So like IT, like help desk people and system administrators, when it breaks, usually the odds are is that that person is going to lose all of their email unless it's stored on a server. Because we don't know how to fix it, only Microsoft knows what to do. So when you trash an email, I can't tell you whether or not it's deleted or not. When you delete an email, there is the deleted items folder, which is like where you have to delete it again.
Right.
But after that point, I can't tell you. But either way, I don't think this program would be able to do that. If it was there, you'd have to probably look at it with the hex editor and get really deep into it. Cool. All right, so this is all I have for the computer half of this, and we can take a 10-minute break real quick, and after that we're going to get into just 1 or 2 networking challenges since we only have like an hour left. All right, so just for the second half of this, we're going to go through some networking basics. We're going to learn how to use Wireshark, and then we're going to go through a Wireshark challenge. And then we're going to go.
You denied it by mistake.
And then we're gonna leave, you said?
Yeah.
Alright, got it.
So just want to give a little bit of an introduction to networking before we actually get into any networking challenges. So all networking communications are usually done between a.
Do we still need our virtual machines open?
You need Windows.
Okay.
You don't need Kali. So yeah, most communications are done between a client and server. The client is the computer that you're using. That's either a personal computer or a workstation in your job. And a server is a centralized computer that facilitates communication and resource sharing. So when you go to a website, that's a client-server communication between your computer asking for the website from a server that's hosting those servers. So every computer on the internet has an IP address. Are you guys familiar with IP addresses?
No.
Oh, okay. So it's a unique number assigned to every device on the internet. And each computer usually has 2 of them. One of them is going to be the local IP, which is your IP inside of a network. I'll explain why that is later. And then the other one would be your external IP, which is shared by all the computers on your network. So it's a 32-bit binary number. I'm not really going to get into that either. So internal IPs are assigned within a network, with one router being assigned an external running NAT. So we demo this, we can see what your IP on your computer is. So for Linux, if you go to your terminal, or if you go to Windows, the command prompt, doesn't matter. You can do this on your actual machine, doesn't really matter. You can type ipconfig for Windows and then ifconfig for Linux. And what that's going to do is it's going to print out all of the information about your network card. So if I can look through mine, see if I can figure out what paste is. Yeah, so this is my PACE IP. So I have a lot of networking cards, like virtual networking cards on my computer, so there's a ton of stuff here. But this is going to be the IP that PACE's network assigned to me. So you should have something similar if you look at yours. So yeah, so if you're on Windows, for CMD it's ipconfig, and if you're on a Linux terminal, it's ifconfig. The ifconfig is the same for Mac.
Change something different, like the piece of the IP address is supposed to start with 10, correct?
Not necessarily.
Okay, that was just the IP you were using.
Yeah.
Oh, then I think it was
All right, I'll move on. So this is what NAT is. NAT is network address translation. So one of the big problems with IP addresses is that we're running out of them. We're actually very close to that point, and so what people have tried to do is try to implement something called IPv6. So we're using IPv4, and the address you're looking at is IPv4. But IPv6 quadruples the amount of, actually more than quadruples, the amount of IPs that are available. So that's good. But to combat this problem, NAT was invented so that every computer doesn't have to have a unique IP address on the internet scale, but they have to have a unique IP address on the internal scale. So every computer is assigned a local IP address, and so what you got from your ipconfig command or ifconfig command is going to be your local IP address. But we're all behind one router that eventually goes out to the internet. So that router is what translates our local IPs and gives us all the same IP. So if you guys were all on PACE's Wi-Fi and you guys were to go on a website and said like, what is my IP? And you look something up, you're all going to have the same outside IP. But on the inside, you're all going to have a unique number. And this is so, PACE has 4,000 computers, but we're only using one IP address. So that's to make everything a lot easier and save space. Cool. So services run on different ports. So what I mean by services is programs. So there are 65,535 ports, and they range from 0 to there. They have different blocks of ports, and this is a good handout that I was going to print out, but I didn't. But it gives you a list of common ports. So from 0 to 1,024, these are what is called the reserved ports, and they are assigned by, I forget the organization name. I think it might be IANA. Is it IANA? It's IANA, so it's a networking association, and they assign these ports to these specific programs, and these are usually the most important programs. So this would be stuff like FTP, which is File Transfer Protocol, SSH, DNS, HTTP, which is how your browser works. So these are things that are set in stone that you can't use. But anything above that is fair game. Like for example, over here, if you ever play Call of Duty uses port 28,960. So these are the ports that, what the whole purpose of them is to make sure that traffic does not get mixed up between programs. So when I'm also on a web browser at the same time that I'm playing Call of Duty, the traffic does not intersect with each other and they go to where it's supposed to be. So that's what ports are. Okay, that's fine. So then I want to talk a little bit about DNS. So if you looked at the handout on the other slide, there was a DNS port, which is 53. When you're using Wireshark, Wireshark doesn't automatically translate the host names. You search for IPs. And DNS servers convert host names to a server's IP for easy access. So what that does is basically, you'll see later, but we have to use filters to look for different communications between your actual computer and an outside computer. And you can't, if you're using Google.com, you can't just simply put, look for website Google.com. You'd have to figure out the IP of that server in order to look at traffic in between you and it, because it doesn't automatically do that for you. That's what DNS does, it translates the IP to a host name, or host name to IP, whichever way you need it. So when you're writing an IP address out to somebody with a port, that means that you're talking about a socket. So a socket will have, so if I'm using my web browser, so a socket would be my local IP address, colon, the port. And if I'm using a web browser, that port's going to be 80 or 443. So that's how that information is supplied so it knows what port to communicate to. So if you've ever done something like that with a colon again, that's what you're doing, you're writing a socket. Okay, any questions? So, this stopped working again, so give me a second. Okay, so I want to talk a little bit about Wireshark. So Wireshark is pretty much like the best tool ever for analyzing network stuff. So what is Wireshark? Like directly, Wireshark is a packet sniffer protocol analyzer, and it's an open source networking tool, meaning it's free and it's constantly updated. You can view the source code, you can contribute to Wireshark, it's pretty cool. So we're going to be working with that today, but here's a diagram that explains when you open Wireshark, there's a lot of junk thrown at you. So this kind of explains what you're looking at. So on the top, you basically have your command menus, which are based on any program you have file, edit, view. Some of them are more useful than others. Then there's the display filter, which is going to be your best friend when you're using Wireshark, because there's a lot of packets that go out inside your computer, and in order to look at them in a clean way, you kind of have to know what you're looking for, so you have to use display filters to sort through everything. Underneath that is a listing of captured packets, so it'll go by number, and it'll tell you all the information that's contained in each packet. And underneath that are the details of a selected packet header. Meaning, I'm not going to get into this, but this is done in the OSI model, which is a networking model. But these are all different levels that a packet will transfer. That's a bad way of explaining it. I'm trying to think of a better way to explain this. So the way the OSI model works is it'll go from the physical layer all the way to the application layer. So the frame would be the physical layer, and as you keep going up, you go from Ethernet to a protocol, to another protocol, to what application is using it, and then you can view the application data. That's going to be some of the most useful stuff is here, because this is the most human readable stuff. All of this stuff is binary, so it might not be useful enough. However, looking at something that says Ethernet will allow us to see MAC addresses of network cards and other important information about a packet. Those will make more sense as you actually do. So when you open Wireshark for the first time, which you can do in your Windows VM, There's two ways to view packets. So people make things called packet captures. It's a PCAP file, and this packet capture file is a pre-recorded capture. But we can make a capture ourselves. So if you have Wireshark open, it should list two things for you. It should list Bluetooth network connection and local area connection, right? And so you're gonna wanna go for the one that actually has traffic on it, which would be local area connection. So if you double click on that, and mine's asking me for a password, it's going to start capturing network packets that go. So as you can see, this adds up pretty quickly. So I had it open for a second, I already have 15, and I'm not even doing anything, right? But if I go to a website, you're gonna see how quickly it adds up. So I just went to Google. I'm just gonna stop the capture that I started, and I have 1,300 packets. So that was all just to go to Google. So it adds up really quickly, and that's why display filters are gonna be very useful. Did everyone try making a capture? You open it up. You might wanna stop the packet capture, which is the big red square in the top left corner. That's really gonna slow down your computer if you keep it. But yeah, as the same thing that was in the picture there. So if I could find something related to the website. So an example for DNS, as I said before, with the bottom display view, there's all the information about each layer of the OSI, and then there at the bottom there's DNS, which is like the be-all end-all, which has all the DNS information that was in that packet. So one thing I wanted to demo for you guys before we got into a challenge is a three-way handshake. So whenever a client connects to a server, if it's using TCP, there's a three-way handshake done. That basically opens up a line of connection between you and the server. So the way that works is, without getting too technical, your client will send a SYN packet, and which stands for, what does SYN stand for? Sync? Okay, sync. And then the server will send back a SYN ACK packet, which is a sync message along with an acknowledgement, which means it's like, oh, I got your sync. And then the client will acknowledge that it got that packet with another acknowledgement. And then after that, the two can communicate and send data to each other. So that's necessary. So I didn't change this slide, so try and don't ignore this real quick. Only work with this. So I want you guys to open up Wireshark and start a packet capture. So the same way you did before, you can just quit Wireshark and start it again. And it doesn't matter if it adds up to a lot of packets, just click on local area connection, and you can't see. But click on local area connection again, and it should start capturing things as I fix it. Okay, so now mine is capturing packets. And what I wanted you guys to do is just visit the club's website. So the club's website is BergCyberSec.club in Firefox. And then after you visit it, wait for it to load completely, and then hit the red box to stop the capture. I'll give you guys a minute for that. Once everyone went to the website with the capture going, you can just
BergCyberSec.org or .com?
.club.
.club?
And then you can stop it. As soon as you go to the website and loads, you can stop it. So now we have, well, at least for mine, I have 2,000 packets. But what we want to see is a three-way handshake. So we know that the three-way handshake happened between our computer and the club's computer. So the IP for that, the communication IP would be 104.37.61.67.4. I'm going to take a picture of that for myself so I can just copy it over to the slide. So what I'm gonna do is to look for all communication between my computer and that website. I'm gonna use the IP address filter, so that's ip.addr. They all have weird naming conventions. So ip.addr, double equal sign is exactly equal to, and then you're gonna wanna type the IP of the website. I should have the command here somewhere. Yeah, it should be, I changed this, hang on. Okay, so type ip.addr, double equals, and then that. Not this IP, but the IP above it.
104.34.167.4.
104.31.67.4. For some reason mine didn't get it. Hang on. Alright, so okay, so I gotta redo this. Let me change the slide real quick. The IP changed. Let me change it for you guys. Alright, so do it with that one instead. And you guys should get something back. Alright, can you guys see the screen? So at the beginning of the communication between my computer and that IP address, we can see that there is the three-way handshake. We can actually see the packets. The first sync packet, the second one that goes the opposite direction from the server to us, the sync and acknowledgement, and then the third packet, the acknowledgement. And after that, the computers talk and they send data in between one another, if that's necessary. Alright, cool. So just one more thing before we do the challenge and then wrap up. So there is a very useful tool in here called Follow TCP Stream. So what you can do with this is you can go into any TCP communication that's found in Wireshark, and you can right-click on a packet, and then there's a button for follow, which you can't see for some reason. Give me a second. Okay, yeah, so this is a button for follow here, and then there's TCP stream. So this is an HTTP communication, so we can actually see the whole communication here. But this would be kind of annoying to do packet by packet, because not all of this is contained in one packet. Packets have a very small and unique size, for the individual size for each of them. So what this does is it follows the stream and puts everything together in a way that we can read it easily. So this TCP stream actually has 7 packets in it, and it starts at packet 110, so we can actually look at all of the data that was in each packet. So that's very useful for when you're looking at, let's say someone sent a file to somebody else and you want to look at that whole communication of the file, so maybe you want to retrieve that file. You can actually follow TCP stream and look at all the data, and then maybe save that data out somewhere. Any questions? Okay. So on the desktop of the Windows VM, there's a folder called Network Forensic Challenges. So they were made by, I forget the name of the company, I think it's LMAG, but it was a nationwide forensic challenge that took place maybe 3 or 4 years ago. And it was just completely based on network forensics. So it was based around this woman named Anne, and apparently Anne had all these packet captures and she was always being investigated for things. So the first challenge was called Anne's Bad Aim. So AIM meaning AOL Instant Messenger, which is dead now, which is sad, but whatever. Basically they give you the packet capture, and the packet capture for this one is going to be evidence 01. So if you can just double click that, and it'll open up in Wireshark, and you'll be able to look at all the packets inside it. But yeah, there's a lot of background story, and honestly none of that's really important. except for the main fact that it gives you the IP of her machine, which is a very important thing because throughout the thing they're asking you, like, who did she send like an important file to, like who is she talking to. So an easy way you can find that is by looking for activity that's coming from her computer, right? So we already know the IP.edir filter, so you might want to use that along with that IP address. So there's 6 questions that come about. There's what is the name of Anne's IM buddy? The first comment in the captured IM conversation, comment meaning chat message. What is the name of the file that Anne transferred? So we know she's sending a file over AOL Instant Messenger. What is the magic number of the file you want to extract? The first 4 bytes. So now we know that there's a file, and we need the MD5 sum of the file. We'll get into that later, I wouldn't worry about that too much. And then we need to find the secret recipe. And I can tell you from having done it, that the secret recipe is actually in a file that she sent over the network. So the course of action here would be first to figure out the AIM information, and then we gotta figure out when the document started transferring. So usually when you see a file transferring over the network, it's gonna look like a lot of identical packets over and over and over again, so that's kinda how you get an idea that, oh, maybe this is like where a file is being sent, because it's the same amount of data. If you were to go on YouTube, and you were to open up a video and watch it along with the packet capture along the side, it's all gonna be a lot of the same formatted data because it's all from the same YouTube video. But yeah, so just open up Wireshark and see if you can find the answer to any of these questions just by looking around. One thing that I wanted to point out before you guys start is that basically new Wireshark is pretty bad, meaning that it removes support for a lot of protocols. So you guys are using an older version of Wireshark that I picked out. And you need to basically tell Wireshark that this is AIM communication. Meaning that, like right now it takes it in as SSL, which stands for Secure Socket Layer, so it just takes it as encrypted network data. But it can be decoded easily with Wireshark. The newer versions of Wireshark don't have it. So what we can do is, we need to decode it. So there is the decode as button in the analyze. Isn't that showing my screen? Yeah, so if you go to analyze, there's the decode as button, and you should highlight one of the SSL packets before you actually go up there. So just highlight packet 23, and then analyze decode as. And once you're there, you can click the plus. And then it says, it already knows that it's an SSL thing, so you can leave that there, and on the right side, there's the current. So that's what you want it to go through, so you want it to become AIM packets. So then you just select AIM and you hit OK.
I'm supposed to capture something else, I only have 95.
No, I don't think I've heard of it. Why didn't it change now? It's supposed to change in a second. All right, so while I'm trying to figure this out, just look around for other things. All right, do it on packet 24, not packet 23, my bad. And over. Just right click on packet 24. Well, not right click, left click. And on the top there's analyze, decode as, and just make sure it looks a little something like that. And then hit save. And you'll be able to read the AIM data. Once you do that, then you should have the ability to find, I would say, probably the first 3 or 4 questions, and then we'll get into how to get the files out afterwards. Just take a few minutes and try and work on it. Alright, can anyone tell me what they found, where they found, and how they found it? For number one. Anyone get anywhere with it? You're sure what's up?
I'm not sure if this is the person's name that they're talking to, or if that's actually her, buddy name, but I got sec558 user 1.
Right. So that's the answer to the first question.
Oh, cool.
So hang on, I'll explain. So the reason why you know that that's the other person, just from looking at it, is because if you look at
Outgoing, right?
if you look at the direction of the, so it goes from her IP to, that could be an AIM server or it could be the actual machine, I'm not sure. But yes, it's outgoing to that person, so that's how you would know right away that that's the other person. So nice. So the second question is, what is the first comment in the captured IP conversation, IM conversation? Did anyone figure out where the first message is? You already kind of did, if you look.
Yeah, it's further down there, right? In message block.
Yes. So there's this message, they talk about a secret recipe. So they do, here's the secret recipe, I just downloaded from the file server, blah, 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 blah. So that's the first message that was in the conversation. So in order to figure out the answer to the third question, did anyone actually get down to the third question and figure out the name of the file that was transferred?
I couldn't find it.
That's okay, good. So there's a very easy way to do this. So if you keep scrolling and you're looking for something that repeats itself over and over again, like I said, like a file transfer.
Oh, the reassemble PDU?
Yes. So a lot of that stuff is definitely like packets being transferred. So if you look over here into the other packet captures, so you just keep watching what happens. Like there's a message acknowledgement, blah, blah, blah. Try to look around, see if I can find anything else interesting before I show you this. Yeah, so if you go to packet 169 and you look at the message that was sent on that block, there's a message that says thanks. So if you know that in the beginning there was the, here I'm sending the file, and then when you get down to a packet 169, or whatever packet I was on, 167, you see that there's a thank you. You know that probably in between there was a file sent. So what I'm trying to say is we have to look somewhere in between to look for where the file was sent. So odds are it's going to be TCP transfer. So we have these reassembled PDUs. So what we can do to look at this and see if this is what we're looking for, we can follow the TCP stream on that. And here we see a lot of junk data. So remember, when we're looking to see if we can find a file that was transferred, what we want to do is we want to look for a magic number, right? Something that would stand out to us, where we could say, oh, this is probably the beginning of a file in bytes. And I don't know anything that starts with star.z. So odds are this is a 8 packet like TCP stream, so odds are it's probably not going to be in this one. So all we have to do is just keep looking around. So this is one big chunk of that. So if I can exit out this display function now. We can go down to even closer to where the thank you was sent, starting at around these packets. So this is kind of interesting here because there's a new like three-way handshake established. So if we follow this TCP stream here, we get a little bit more information. So here we can see clearly that this has something to do with a file transfer because you have a docx file. The name of the docx file is recipe.docx. So that's pretty good for us to know because one, we have the name of the file, which answers one of the questions. And now we know that we're working with a docx file, a Microsoft Word document. So my first thing in my brain that I would think to do if I saw that would be, let's go on Google and look at what the magic number is for a Word file so we know where it starts. And then we can know how to get rid of, because there's a lot of junk data up here. Like this is all junk data. So docx files start with the magic number PK. So all this stuff before it, if we save it and we try to open it in Word, it's not gonna work because it doesn't actually have the beginning. OFT stands for Open File Transfer, just for the record. So it's right underneath it also. So what we want to do is we want to take all of this and we want to do something called file carving, which is taking out all the junk data from the beginning and all the junk data from the end and just making it into a file that we can actually open and work with. All right. So if we scroll to the bottom, we have also some more junk data at the end. So it starts with OFT again. So that's kind of how we know that the Word document has ended. It also indicates this by showing us a different color. So that kind of gives it away. But yeah, so we know that this part is not going to be part of the Word document either. So we basically have to carve around this PK from the beginning and also from this OFT at the end. So we can do this with a hex editor, and I'll show you guys how to do it. So when you're working with files, you don't want to save it as ASCII because you want the actual raw bytes, you want the hex that you can work with. So we're not going to save this data as ASCII, we're going to save it as raw. So if you just change it to raw. And then you can hit save as. And just for, just to stay consistent, I'm going to save this file on my desktop as recipe.docx, because we know that's what it's supposed to be called. Right, so if I go on my desktop, I have this docx file called recipe.docx, and these machines don't have Microsoft Word stored on them. If I was to try to open this right now, it's literally just going to give me this data, which is not like helpful to us at all. But also on top of that, if you actually have Microsoft Word installed, it would notice that it's not right, something's wrong with it, and it would try to run through an auto recovery and try to fix the bytes at the beginning and the end. But I've done it a few times. I've only seen it work like 50% of the time. So you're better off just doing it manually. So what we can do with this, I'm just going to delete this because I might have already ruined it. We can open this in a hex editor, and just for convenience, online there's a hex editor that I'll navigate to right now. If things could open the right size. So it's called hex edit, but it's formatted like this. So it's hexed.it is the name of the website. And going to that, it gives us an online hex editor that I find that is easier to work with than actual like local hex editors. So here we can open a file. We can go to the desktop and we can give it the file that we pulled out, which would be recipe.docx. And here we can actually look at the bytes of the file that we're working with. So as we said before, we need to take out all the way up, leading up to the first PK, and then we need to take out from the end with the OFT. And so with this, I can highlight these. Just keep deleting until we reach those initial bytes, which would be right here. So this is where I'm going to stop it, because we need the first initial 4 to be the PK. So with this stuff that's highlighted in blue, we can right-click it and delete the selected bytes. So now we can see that at the beginning, we start with a PK, which would allow a computer to know it's a Word file. But as we said before, there's also a lot of junk at the end. So if we go to the end, we figure out where OFT2 comes up again, and we can get rid of this also. And delete the stuff too. So now, if we did this correctly, we should have a working Microsoft Word document. because there's no stuff at the beginning and no stuff at the end. So we can export this, we can save it to, I don't know, downloads folder. And then open it up, and WordPad will actually open it now, rather than like a normal text edit or whatever. And rather than just showing us the bytes, because when we took it out of Wireshark, we saved it as raw, so the original file, if I resave it and show you guys again, when it opens up, it just gives us all the junk data that we were basically seeing inside Wireshark. But now that we fixed it and it actually knows how to work with it, it actually opens up correctly, and we can actually read the recipe that was sent in between the two. You got any questions? Do you guys understand what happened? Anything? Because this is my last one. That's why I'm asking. Any questions about the whole workshop? In general?
No.
Alright, well, no questions, then that's it. Thank you for coming. I'm gonna upload a copy of the PowerPoint to the club website, along with write-ups for all the challenges. There's 2 more challenges in here that I didn't want to get into them, but there's write-ups for them if you want to try them on your own. They're also in that folder. The second one operates sort of the same way, and the third one actually involves working with an Apple TV, which is pretty cool. So yeah, if you want, you can go take a look at them on your own.